In the first example, we're going to look at the rate of change of y being proportional to y, and then we have a list of information, or at least some written down information, that we're going to use to find the value of y when t is 3. So let's read through that again here. So it says that the rate of change of y is proportional to y. So to me, that means dy dt, t is the independent variable here in this case, is equal to k times y. In the concept notes for this unit, or this lesson, I showed you how you can solve this differential equation, and you're going to get y is equal to a constant a times e to the kt power. What we're going to do is we're going to utilize the solution to that differential equation, and we're going to try to figure out some information by the given information. So t is equal to 0 here and y is 2 is going to be our first thing we're going to take a look at. So if we can substitute in here, we've got 2 is equal to a times e to the k times 0 power. Well, e to the k times 0 power is the same as e to the 0 power, which is 1. So using our first given information, t is equal to 0 and y is equal to 2, we've successfully found the value of a. So now we know that y is equal to 2 times e to the kt power. We still don't know what k is. Let's see if the next piece of information, which is t is equal to 2 and y is equal to 4, will help us with that. So now we're going to utilize our new equation with the new value of a that we found. And we're going to substitute in 4 for y, and then we'll substitute in 2 for t. So we have 4 is equal to 2 times e to the 2k power. Move this down a little bit. So we're going to divide by 2 on each side. So if we divide by 2, we have 2 is equal to e to the 2k power. We'll change this into a logarithm. So that's log base e of 2 is equal to 2k. Remember, the exponent always goes on the other side of the log. A log base e is really just the natural log. And then we're going to have to divide everything by 2 to find k. So k is going to be equal to the natural log of 2 divided by 2. If we take a look at our equation now from above, we can write in that value. So we've got 2 times e to the natural log of 2 over 2 times t power. So there's your k value substituted in. We're going to use this last equation to help us to solve for the value of y when t is equal to 3. So the y is what we don't know. So we'll write that down. And we do know now the value of t is 3. Simplifying this just a little bit, we have 2 times e to the 3 times the natural log of 2, oh my gosh, over 2 power. And if you wanted to, you could mess with this just a little bit more. This would be an acceptable solution right here. So we're going to draw like a box in there and say, okay, that's it. If you wanted to play around with this a little bit, sometimes in the multiple choice, the answers look a little bit different. So you're going to have 2 times e to the natural log of 2 power times e to the 3 halves. Excuse me, that won't work at all. That'll be, let's see, that's got to be this right here. We'll just erase that right now. So we've got e here to the natural log of 2, and then we'll raise that to the 3 halves power. So that'll be 2 times 2 to the 3 halves power, and that's 2 to the first, which is also 2 over 2. So we've got like 2 to the 5 over 2 power, or the square root of 2 to the 5th. All of this, when you type it in your calculator, should be equal to 5.657. So that'll be about 5.657. And on the calculator section, this might be the answer that you want to write down.